Good morning, Hopewell. This is Mr. Steinberg. Today is day 1 of your e-learning assignments. We're going to focus in on sections 1, 2, and 3. I'm going to record each video one section at a time, but feel free to pause and replay these videos as many times as needed. Today's lesson talks about patterns of numbers, which we call sequences. Our warm-up for today has 4 patterns of numbers, which we are then asked to find the next 3 terms in each pattern. Starting with our first example, take a look at the numbers 33, 25, 17, and 9. The first thing I notice is they are decreasing, but how are they decreasing? I'm thinking back to when I learned about this in algebra. This is something called a constant decrease or a linear pattern. Well, each term is 8 less than the previous term. If I subtract 8 from 33, I get 25. If I subtract 8 from 25, I get 17. And so on and so forth. So let's find the next 3 numbers in this pattern. 8 less than 9 is positive 1. 8 less than positive 1 is negative 7. And 8 less than negative 7 is negative 15. So our first pattern is what we consider to be like a linear pattern and has a slope of negative 8. Go down below to our second pattern. This one might be a little tougher to figure out. The numbers 2, 8, 18, and 32. They're increasing in value, but not by the same amount. If I add 6 each time, I don't get the next numbers in the sequence or pattern. So let's see, if I multiply by 4, I also don't get the next numbers in sequence. The trick to this one is thinking about half of these numbers. Half of each of these numbers, 1, 4, 9, and 16, are the perfect squares. Each term is 2 times a perfect square, in order starting with the first perfect square of 1, then 2 squared, 3 squared, 4 squared. So 5 squared would be 25. Doubling it would give us 50. The term after that would be 36 times 2, or 72. The next perfect square after 36 is 49, and doubling that gives us 98. This pattern will continue to go on forever. Question 3. 18, 6, 2, and 2/3. These numbers are all decreasing, but how? Think about what the next numbers could be, or what the relationship between each of these numbers is. Each number is 1/3 of its previous number. For example, 2/3 is 1/3 of 2. The number 2 is 1/3 of 6, and the number 6 is 1/3 of 18. So this pattern is multiplied by 1/3. So what are the next 3 numbers in this pattern? After 2/3, we'll get 2/9. 2/9 times 1/3 would be 2/27. And the next number in this pattern will be 2 over 81. So this pattern reminds me of exponential decay, whereas the first pattern reminded me of linear functions or constant decrease. These are the 2 types of patterns we're going to be focusing on in our packet mostly, but then again there are other patterns. This last one sort of makes sense to me. It begins with 1, then 22, 333, we got 4,444, but the way I said 333 kind of gave me a clue. I have 1 1, 2 2s, 3 3s, 4 4s, and 5 5s. So our next number would be 6 6s, followed by 7 7s, and finally 8 8s. This pattern just has the number of terms. Each term has an additional digit, and it's made up of those numbers. These words down below should help me explain how to talk about all of the patterns that we studied today.